Good morning, and you're all very welcome to this morning's Signpost webinar. We hope you're keeping safe and well wherever you're joining us from today. Today, we'll be discussing past, current, and future fertiliser trends in Ireland. The government's Climate Action Plan has set out an ambitious target to reduce chemical nitrogen fertiliser use by 20% by 2030. So today we're going to be hearing how Irish farmers are driving down the use of fertiliser and the positive impact that this is having on farmers' pockets and the environment. And we're delighted to be joined by Mark Plunkett, who is Training and Development Specialist with Teagasc at the Signpost Programme in Teagasc, and Pat Murphy, who you all know is head of the KT Environment Programme. Pat, during your time that you're not hosting webinars, you're also involved in some of the research activities and developing some figures around this area. Could you tell us a little bit about what you've been doing in this area?
Yeah, so I suppose for the last more than 10 years now, Mark and I have been looking at trends in soil fertility. We take in between 40 and 70,000, depending on the year, samples each year. And each year we do a fairly thorough analysis on that data and looking at it over a time period to track soil fertility and what's going on in soil fertility, which is very much related to the use of fertilizer and to the use of lime. And I suppose it's a key element of our ability to produce crops and to produce grass for our animals, but it's also a key indicator of our ability to effectively use the fertilizers that we put out, and to maintain that fertilizer in as productive and not to lose it to the environment. So it's an absolutely key indicator of what's happening on the ground, and for the future, how we will manage to achieve the targets that were set, both for production and environmental.
Right. Okay. Thanks, Pat. And yeah, no, look, I know that the figures, you have a lot of detailed figures, both from soil samples, and then we also have industry figures as well. Mark, you've recently made a move. You were working very much as a specialist in this area until recently.
Yes, Mark, I was working in the whole area of soil and plant nutrition, working with advisors, specialists, farmers, the industry. And I'd say recently, yes, I've moved across to the Signpost Programme, again, working the whole area of training and development. And again, fertilizers, will be a component of that. And I suppose maybe putting the figures on it around climate, around, emissions, whether it's nitrous oxide, methane, ammonia. So yeah, I suppose getting my head into that whole space, and fertilizer is a big part of that. So yeah, very much looking forward to the challenge ahead, and in the years ahead to, making a difference, and again working with everybody involved in, I suppose, making that transition, Mark. Around, as we say, around the whole area of fertilizer use, and I suppose the sustainable use, and meeting the targets there as laid out in the MAC or in the Climate Action Plan, in terms of reducing emissions from agriculture.
You've been out on the ground meeting with farmers, industry. What's the overall reaction to this message that you're broadcasting, that we do need to look at the fertilizer that we're using, or the amounts and the targeting of that fertilizer?
Yeah, I suppose, look, it's getting people on track. Like, I suppose in agriculture, we have a plan, we have the MAC, we have the technologies, and people are taking the technologies on, and I suppose it's working with farmers around the language. And I suppose, we're fortunate in that there's a lot of the technologies there, as well as reducing emissions, whether it's nitrous oxide or methane. They put money back into farmers' pockets as well. So there's a cost benefit there. In terms of adopting the technologies, and a lot of the technology we have, the science is very solid, they're proven, and they will deliver in terms of meeting our climate targets.
Great. So I know you have a shared presentation, so maybe if you want to share your slides with us, and we'll kick off the presentation. Just while you're doing that, to remind everybody that There is a Q&A tab at the bottom of the screen. Please do use it, and we will put your questions to both Mark and Pat at the end of their presentation. And the session is being recorded and is available, or will be shortly available, on the Teagasc YouTube channel, as well as the presentation. And if you want to catch it while you're on the move, the webinar is available as a podcast on all of the popular podcast platforms. So, Mark, I'll hand over to you, and we'll chat.
Well, in fact, I'll make a start. I'll let Mark do the vast bulk of the work here this morning, but I'll start out. And I suppose what we're going to look at is just a little bit of background, and then we'll look in a little bit more detail at lime use and soil pH trends, which is a key indicator of soil fertility. And we'll then look at, I suppose, fertilizer use over the last decade and a half, and even a little bit longer, and matching that to soil P and K fertility trends, and how the two of those interlink and that important linkage. And then we'll look at some of the benefits of soil fertility, and we'll look at some of the solutions to reduce nitrogen use in particular. And I suppose getting on to the data set that we have, for a long number of years, DAFM gather information on fertilizer use annually, and that's detailed by product, and it's been based on sales. And we're at a change point in that data, because from next year onwards, we will have the fertilizer use. So it will now go from being a kind of an entire industry-based measurement of fertilizer use to a farm-by-farm, a detailed analysis at farm level, which will be available to the farmer and available to the advisor. And that will make that a significant tool in I suppose, helping to guide farmers to the effective use of fertilizer. And on the other side, Teagasc provides soil analysis services to its clients. And we have a comprehensive data set going back to 2007. And with that data set, we track it. It's pretty much the first job I do when I come back every year is to run the figures for the previous year and update the tracking. And each year, Mark and I bring out a publication in relation to what's happening to the trends in soil fertility. But that data and that soil fertility data combined with fertilizer use is something we've been using very heavily to drive advisory messaging on fertilizer use and soil fertility. And I suppose what we're trying to do is avert crises, in terms of there's been a number of times where it looked as if soil fertility was declining, and messaging from advisors in terms of lime use, in terms of P and K use, were required to bring usage back up to sustainable levels. And I suppose the question that you could ask is why is it so important to analyze this data? But soil fertility and combined with crop nutrition is the very basis of our livestock systems. And on top of that, then, for nitrogen, that soil fertility is absolute key to the efficiency with which that nitrogen is used. So the drive for reduced N is heavily based around us having a very high level of soil fertility, and doubling that up, our ability to grow clover in particular, which is a lot of the basis as well of us being able to reduce nitrogen use, is again dependent on having high pH and high P and K levels in our soils. But in relation to phosphorus and nitrogen, we are trying to make sure that we are using our nitrogen efficiently, and that we're achieving balances between the use of nitrogen and the losses to the environment. And again, with phosphorus, the same story, making sure that the phosphorus that we're applying for crop use is not lost to water. And we have a lot of targets have been set out for us in this respect. Targets in the Climate Action Plan, but also at a European level. Farm to Fork, I think, sets out the target for us very well in that it has asked us to reduce the usage of nitrogen and chemical fertilizer by 20% in terms of usage. But it set a further challenge to reduce the losses to the environment by 50%. So it's not just a reduction in the usage that we've been asked to achieve, it's to use it a lot better, a lot more efficiently, and stopping the losses to the environment. And just to look at the key pathways, so it's not the entirety of it, but some of the key losses when we apply nitrogen, and particularly CAN in the form of CAN, we tend to lose nitrous oxide to the air. Ammonia is the other big concern in terms of losses from fertilizer, and that's lost primarily from urea-based fertilizers. And then for on the water side, nitrate losses tends to happen down through the soil profile. As we get a wetting of soils, it takes the nitrate down with it into the subsurface water, and then that goes back up to the rivers. Phosphorus is by and large different, with the losses of phosphorus tending to be in particulate matter and in solution across the surface of the soil and into rivers. And that means we tend to get problems with phosphorus and problems with nitrates in different parts of the environment. So there's a huge challenge there. And I think what I'll hand over to Mark now, and just to I suppose, give us an insight into how we can potentially meet some of those challenges through better use of fertilizer. Mark.
Okay, that's super, Pat. Thanks for that super introduction. As I say, it's a very good point to hand over. I say, look, I suppose it's a two-pronged approach in terms of that we're trying to reduce nutrient losses in terms of, in terms of water, and also in terms of air quality, in terms of nitrous oxide and ammonia. So look, I suppose this morning, as they were very much a focus on fertilizer, but look, the basis to getting fertilizer efficiency very much starts with lime, and I really can't talk about fertilizer unless I talk about lime first. So again, what I have here is we have the lime usage data from the Department of Agriculture over the last 50 years, and you can see what's happened. So I'm going to walk you through maybe in three phases. So if we go back to the 70s and the early 80s, we were using somewhere in the region of about 1.68 million tons of lime. So a whopping amount of lime. There was a lot happening back then in terms of agriculture. And I suppose the big drivers that we would see, as well as agriculture going through a big transition back in that window, there was free soil sampling, and also there was a liming subsidy. And you can see in those years, there was only 2 years out of that first window there that we spread less than 1.5 million tons of lime. So again, a big requirement nationally for lime. Again, very much linked to our climate in terms of rainfall, and also the type of soils that we have in terms of regulating or controlling soil acidity. If we look at the next window, then again about 30 years, again lime usage reduced significantly. We're back to somewhere around 800,000 tons of lime, so nearly 50% of what we spread in the previous decade and a half. And again, you can see in those years we seldomly hit over 1 million tons of lime. There's only sort of 2 occasions there, even 3. And again, that was very much linked to the schemes as in terms of reps, and also weather is also a big factor that we have to manage as well. You can see 2012 there, we're back to just above 500,000 tons, and again we picked up the remainder of that lime in 2013. If we move it on then to in the last, I suppose, decade, lime usage has increased. You can see there is a lot more of the bars closer to the 1 million tons. And again, in the last 2 years, we have managed to exceed that usage of lime. And you may ask the question, what's happened? If we looked at the last 20 years, that, we're quite familiar with. If I just draw a line there, you can see from 03 to 12, again, you can see lime usage was only averaging about 700,000 tons. So you can see 5 out of the 10 years were just above 500,000 tons. And again, this was something that, again, we identified and we worked on. Again, there was a soil fertility knowledge transfer awareness campaign kicked off in 2012. Seems a long time now, but again, if we look back over that time frame, again, down to people on the call, advisors, again, there was a big push on there. There was a lot of research going on. And look, we managed to hit somewhere around an average of 1 million tons of lime in that window. And I said the last 2 years we're hitting sort of 1.3, 1.4 million tons of lime. So again, if we bring that on, as Pat's talked about, so we've seen a 30% increase in the last decade compared to the previous decade. Again, if we look at what happened on farm in terms of soil fertility trends, so again, if we look, I suppose the driver of the soil for the soil fertility campaign back in 12 was that we had a lot of soils. Only 35% of our soils were optimum for PK and lime. And again, if we look at the enterprises, dairy had 33% of samples testing with optimum, dry stock 31, and tillage 60%. So again, this was something that we needed to work on. And again, we kicked off a soil fertility campaign with a big focus on lime. Back in 2012. And again, if I just draw another line, 2016. So again, in terms of soil sampling, it's very cyclical. So again, we're sampling every 4, 5, 6 years. So you can see, we did see improvement in the years thereafter. Like 2016 was a big soil sampling year. We hit about 65,000 samples. And again, the years thereafter was a big number of samples taken as well. But we went up to 64% of soils with optimum lime. So again, farmers did take on the message. Again, there was a lot more lime spread. And again, we got a good response in terms of the results that were coming back in through the advisory service. Also in 18, there was a nutrient efficiency program, again, targeted at the more intensive farmers in terms of being more efficient with how they use fertilizer. And again, you can see today there's somewhere around 53% of our soils optimum in terms of pH on dairy farms, dry stock 43%, and tillage 78%. Again, looking forward to the years ahead, again, we see a downward trend there. And again, we are using more lime in the last 2 years. We also have investment at government level in terms of the National Liming Programme. So again, that will take an effect. And I believe that the thinking around lime and the importance of lime is very much alive out there on farm, that it is going to be a key enabler in terms of us meeting and maintaining that target of 300,000 tons of chemical fertilizer. Okay, if we bring it on then in terms of fertilizer use, so again, we have about over 30 years of data there on the slide for NP and K use. And again, I suppose just maybe to draw your eye to maybe some bits of information first. So I suppose, look, back in the 90s, in the early mid 90s, we were using a lot of P's and K's. Again, if you compare that to today, we're only using 45% of the P and about 40% of the K. So again, that is a concern. And I suppose if we also look at the product mix, we use a lot of, say, the high PK products, the O730s, the O1020s. Now again, that has changed over the last number of years. That there is a bigger, I suppose, range of products out there and a lot more blending going on. But again, on the grassland side, you would like to see more of a return to those high PK products in terms of building and maintaining soil fertility. So again, in the next little while, I'm going to have a look at 3 phases. I suppose significant, events in the data or in that fertilizer use data. You know what I mean? So there's three windows there, and again we'll have a look as regards to current, what's happening, and maybe what we should be doing in the years ahead. So again, if I bring you back to between 07 and 2010, and even prior to that, you can see there was, in terms of at farm level, there was decoupling, there was a reduction in livestock numbers, and again we were coming down off the high usage of both NPKs into that window in 2007 to 2010. So again, look, back then we had a fertilizer crisis. Again, those high oil prices, those low product prices in terms of meat, milk, and grain. There was also a reduction in production capacity in terms of the fertilizer plants. There was a lot of older plants taken out of production. So again, it limited supply. And again, between high energy prices, limited supply, fertilizer prices increased by 500%. And again, I suppose also in that window as well, nutrient legislation came in. But again, you can see what happened. Fertilizer use, again, we hit an all-time low. 306,000 tons of nitrogen, 20,000 tons of P, and 52,000 tons of potassium. So again, we can bring that on to the National Fertilizer Use Survey of 2005 to 2015. And again, we can pick up during that window use at farm level was extremely low. Like if you take the likes of, say, dry stock there, stocked at 2 cows per hectare, we've a requirement of 10 kilos. And you can see on cattle farms, the usage was back to about 2 kilos per hectare. The same on dairy farms. Again, maintenance levels of pea is about 14 kilos of pea per hectare. And again, you can see a significant reduction. They were far from the maintenance line in terms of maintaining soil pea on the grazing ground. Sorry, in terms of potassium, again, the same. You can see there, potassium levels were well back. So on dry stock, the maintenance is about 15 kilos per hectare. And again, you can see we're back to sort of 8 to 10 kilos of K per hectare on dry stock farms. And dairy farms are well off. The maintenance there is about 30 kilos of K per hectare on the grazing ground. And you can see levels were back a lot. We're back by, up to 200% on dairy farms. And the same on the tillage side of the house. Again, K levels were back significantly. Like if you take tillage crop, requires, say, spring barley requires about 75 kilos of K per hectare. And again, use back to, between, 8 kilos to 12 kilos in that window. So again, when you're below maintenance levels, you're eating in or you're mining both soil P and K, and again, you're running down soil fertility. So again, if we look into the database in that window, you can see what happened. So again, when we stopped applying or reduced our application of P's and K's, you can see there in 07, we had about 40% of soils at index 1 for P, and that went to nearly 60%. So we picked it up very, very quickly in terms of the soil test results. The same on the potash front. Again, we had about 40% at index 1 and 2 back in 07, and we've seen that rising to 53% in the years thereafter. So again, it is important to look back to see its impacts in terms of fertilizer use. Okay, the next window there, if we look at between 2017 and 2019, so I suppose from that low in 09, it took a long number of years for the use of both P and K to recover. And again, we've seen that recovery between 2017 and 2019. It took us a long number of years to get back to where we were, say, in the early 2000s. And again, look, we hit record usage of nitrogen at 408,000 tons, phosphorus 46,000 tons, and K 120,000 tons in terms of maintaining the system in terms of P and K. And again, look, if I bring you back, what are the drivers back then? So again, we had a drought in 18. So again, very, very dry summer. We had eaten into silage stocks. And again, I suppose, we were trying to avoid a fodder shortage come the winter. So again, on the back of that, more fertilizer was spread to build reserves for winter fodder. Also, milk quotas were abolished back in 2016. So again, we were increasing productivity. Profitability was good in that window, and also as well to remember, we had probably some of the lowest fertilizer prices back. Like nitrogen was less than 200 euros per ton, if I recall, back during that time frame. So again, okay, what effect did that have? So again, we're on a rising plane. We're increasing productivity levels. There was a big demand for P and K. And again, we did pick up an improvement in terms of soil P. Like for example, again, we went from over 60% of our soils at index 1 and 2, to just, somewhere around 53%. Now again, look, this is still a lot of soils that are, very low or low in terms of P supply. And again, we've seen the same effect in terms of potash, that we had about 55%, over half our soils index 1 and 2 back in 16, and then with the increase in fertilizer use, that went back to somewhere in the region of about 42% of our soils at index 1 and 2. So again, we can pick up the change in fertilizer practice in the soil test results over time in terms of the trends. Okay, the final window then, again, if we look at the more recent years, 2020 to 2023. So again, I suppose just to maybe refresh us as regards what has happened in that time frame. So again, we had COVID-19, back in late 19, early 2020. Also, it was a time of high energy prices. Fertilizer price was rising, if you remember, in those years, and again that was impacting on fertilizer use. We also had then the Russian-Ukraine war, so again that drove prices even further again in the spring of 22. Also, there was a reduction in production capacity. The normal channels for fertilizer supply into Europe had changed. There was also sanctions in terms of trade. There was trade disruption. There was also freight had got quite expensive as well. There was a number of ships decommissioned during those years, and again, there was sort of a limited. So there's a number of factors, I suppose, driving price. I suppose the one positive during that window is that product prices were high. Grain, milk, meat were at all-time highs in terms of product prices. So that did shoulder the impact of the high fertilizer prices encountered during that window. So and look, in terms of usage in 2022 again took a big hit. Again, nitrogen was back by 14%, and again, I suppose concerningly, phosphorus was back and potassium was back. 26% phosphorus and potassium back by 24%. So again, price having a big impact on usage. I suppose the only positive there is that we were at a high usage, a level usage in the previous year, but again a significant reduction in usage. There is figures out there for 2023. Again, there is industry figures out there at the minute, and again, nitrogen has taken again a further drop of up to 18%. We're at somewhere around 280,000 tons of nitrogen. Phosphorus again back about 10%, and potassium back about 12%. So again, look, with fertilizer use back, there is a positive in there in terms of that we are meeting our chemical nitrogen target for 2030 as in the climate action plan. We're meeting both targets, and even in the MAC we're meeting that target as well at 280,000 tons. But of concern is, we are in an era of reduced nitrogen usage, and we have to use that nitrogen more efficiently, and P&K is essential to using that nitrogen as efficiently as possible. In terms of a positive, we are probably in one of the biggest years in terms of soil testing. We're here in Teagasc, we're at about 70,000 soil samples plus for 2023, which is one of the biggest years in the last 2 decades. But I'm encouraging everybody on the call, now is the time to take action. If you haven't soil tested in the last 2 years, get soil samples taken over the coming weeks and months, and again, plan your fertilizer, put a fertilizer plan in place, and make sure that we deliver sufficient P&K to maintain nitrogen efficiency in 2024. Okay, so look, you might ask the question, why build soil fertility? And again, it's very much linked to nitrogen use efficiency. So again, in terms of phosphorus, where you maintain soils in that sweet spot or that sweet zone at index 3, we can improve nitrogen efficiency by up to 15% compared to an index 1 or an index 2 soil. This is again more work from Johnstown Castle here. So again, it just shows the importance of soil fertility in terms of driving nutrient use efficiency. So again, if I can draw you in terms of, if we've low soil pH, low P&K, we're at about 35% nitrogen efficiency. As we improve pH, we go to about 51% nitrogen use efficiency, and then we can step it up, where we optimize soil P, soil K, and then optimum soil fertility with PK and lime. We can get 63% nitrogen use efficiency. Like currently on grassland, we've about 18% of our soils at optimum PK and lime. So again, there is a lot of work to be done there. On tillage, we're at somewhere around 22% of our soils with optimum PK and lime. Okay, so again, in terms of climate, again, another benefit of lime, as in terms of an enabler, in terms of reducing nitrous oxide emissions. So you can see there where we maintain higher soil pH levels. Again, we drive efficiency, and we also we can reduce nitrous oxide emissions by up to 39%. So again, lime, a key technology in terms of reducing nitrous oxide emissions. Also in terms of soil P fertility. So again, this is another measure in the MAC. So where we can optimize soil P fertility, we can also reduce nitrous oxide emissions as well. So again, work from Johnstown Castle here on a moderately drained soil and a well-drained soil, we can reduce nitrous oxide emissions by moving from index 1 to index 3 by 16 to 25%. So again, big benefits in terms of getting soil fertility right, in terms of reducing our gaseous emissions. Okay, look, in terms of, we're talking about fertilizers. So again, in terms of nitrogen type, so again, I suppose traditionally we have been a country where we use CAN and urea. So again, from an ammonia point of view, again, CAN is good, the little ammonia emissions, urea potentially high ammonia emissions. And again, in terms of greenhouse gases, again, CAN is there's significant emissions in terms of nitrous oxide from the nitrate component of CAN, where urea has a very low N2O or nitrous oxide emissions. So again, look, in terms of switching from urea to protected urea, you might ask the question why. The big benefit here is that we can reduce ammonia emissions by up to 78%. Again, this research is very solid. It's going on for over 10 years here in Johnstown Castle. And again, the NBPT type products where you have a good level of inhibitor on them, that's the level of ammonia emissions that we can achieve. And again, the other switch, when you switch from CAN to protected urea, again, we can reduce the nitrous oxide or the greenhouse gas emissions by 71%. So again, there's a double win here by switching to protected urea as the main nitrogen source. And it's probably the most effective technology that we have in the toolbox in terms of meeting our climate action target of a 25% reduction. Like on an intensive livestock farm, we can achieve a total farm emission reduction of between 7 to 8% in terms of carbon emissions. So again, it's a key technology in terms of us reducing or meeting our targets in the years ahead. Okay, so again, I have sulfur here as well. So again, a lot of work being done in the last number of years here in Johnstown Castle by Claire Aspel and Patrick Forrestal on the role of sulfur in terms of end-use efficiency and also reducing nitrate leaching. So again, where we have sufficient levels of sulfur in terms of fertilizer, CAN with sulfur, we can reduce nitrate leaching by 63%. So again, a key technology, sulfur. The same on the silage ground. Think of your silage ground where you have slurry and CAN. Again, by having sufficient levels of sulfur in there, we can reduce nitrate leaching by up to 60%. So again, something as simple as sulfur, again, balance, very important in terms of reducing or increasing nitrogen efficiency and reducing leaching. Okay, so folks, look, we are in I suppose, a different place in 2023 and in the years ahead between now and 2030. That the challenge is that, we have to meet that target in terms of reducing our emissions, that 300,000 tons of chemical nitrogen. So again, what can we do or what are the tools in the toolbox? So again, look, soil testing, again, we're in a good place. We have a lot of soil samples taken, especially in 2023 and in previous years. There's still time to take more soil samples, but it's very much back to, improving soil fertility, improving soil structure, improving soil health in terms of balancing that nutrient supply. So again, it starts with soil pH, supplying the balanced supply of both, P and K. Sulfur is a key nutrient in there in terms of improving nitrogen efficiency, and then putting on the correct amount of nitrogen based on your soil type or based on your system to drive that system or fuel that system, in terms in the years ahead. Lime, look, I can't overemphasize the importance of lime. We are in a good place. There's a lot of lime to go out on farms. And again, if weather conditions improve over the coming, weeks and month, again, I will be getting lime out. As I say, there is a lot of lime in the system to go out there between now and next spring. But again, it's a key tool in terms of reducing nitrous oxide emissions. It's also an enabler. It's a technology that can enable us to reduce our nitrogen, like by improving the pH from, say a pH of 5.5 up to 6.3, 6.5, we can reduce our nitrogen requirement by about 60 kilos. And again, that puts money back in our pockets. That can save us around 72 euros of €72 per hectare in reduced chemical end costs. Slurry, again, look, we've made massive progress in terms of slurry. The technology is moving out on farm, and we have moved from the splash spray to the low emission technology. And again, you know, the biggest crop we have in this country is first cut silage. And again, you know, by moving the slurry application into the spring of the year, we can reduce that crop requirement by about 20 kilos per hectare. So that's about 15 to 20% of the crop's nitrogen requirement coming from slurry. And again, you know, low emission spreading technology, that is the way to do it. And again, you can reduce your fertilizer costs by about €45 per hectare. In terms of protected urea, we've talked about it, but again, there is ongoing work here in Johnstown Castle, and we can show that we can reduce the rate of nitrogen by about 10% in grassland, where we use protected urea over straight urea. And again, there's also a significant cost savings there of in the region of 20 to 25% in terms of the farm nitrogen fertilizer bill. And the final technology that I'll put in on the table here this morning is clover and multi-species. We've a lot of work done on clover, a lot of work ongoing on clover, and again, a lot of work being done on multi-species. But again, you know, we can replace between 50 and 150 kilograms of N per hectare per year, and again, put money back in our pockets, somewhere in the region of 60 to 180 euros per hectare. So with that, Pat, I'm going to hand back to yourself to maybe give us an idea around the fertilizer strategy going forward.
Okay, thanks, Mark, and I'll get you to edge this on as we go through it. Okay, so I suppose just looking at what's happening over the last couple of years, and just looking at, I suppose, the ask and the consequences on what that ask can deliver over the next couple of years. So we've seen a drop in overall nitrogen use from 400,000 tons in 2021. Looks like it'll be in or around, and maybe even a little bit less than the 300,000 tons, but there is a little bit of an adjustment for stocks there. But I suppose that the target is now to try and maintain that level going forward. So I know there's been a lot of reasons for it, but what we're trying to do is to maintain that. If we then look at the can-based urea, so what I'm talking about here is pure can, and also the low pK products such as cut sward and pasture sward. Effectively, problem there is they're high emitters, as Mark pointed out, of nitrous oxide. And over the next couple of years, I think we need to be targeting to shift some of the can to protected urea, but also to shift some of it to the high pK compounds, and particularly a shift away from some of the low pK compounds, because the reduction in the amount of nitrogen is by virtue of the fact that we have, I suppose, a set number of products with mixes of P and K. We're also seeing the high level of reduction in P's and K's. So to counteract that and to get back to somewhere near the amount of P and K, we're going to need to shift from some of the can-based products to the higher PK DAP-based products, the likes of 18-6-12. I won't put a foot in it. My view, we need to take urea out of the system altogether and put it in as protected urea. And I mean, there's very good reasons behind it. That we're looking at urea in terms of its loss of ammonia to the atmosphere. And ammonia is a gas which has damaging effect on both on the environment and on human health. And it also is attracting a huge level of, the potential for a huge level of fines at a European level for not meeting targets. So we need to make that shift also. So I suppose what we're saying is a target of 300,000 tons in 2025, 40% of it can-based, all the urea shifted to protected urea, and an increase in the high PK products. What that will deliver for us as an industry will be lower overall fertilizer costs for farmers, will reduce the fertilizer-based greenhouse gases by 40% versus the 2021 figure. Massive reduction. not where we need to be by 2030, but a hell of a long way down the line. The next issue, Mark, if you just flick it on there. Yep. We'll reduce fertilizer ammonia by 50% again, which will bring us along with the use of less, very close to the targets we have for ammonia emissions, and avoid potentially those fines and get the benefits from human health and environmental health. And also the general reduction in nitrogen use will help reduce the losses to water. So if we can nudge our fertilizer use in that direction, we will achieve a massive amount in terms of reduced impact on a whole variety of environmental factors, and also improve profitability at farm level. So I think that's it, Mark.
Okay, great. Thank you very much. That was a lot of facts and figures there, but no, you went through them very gradually. And look, we have a huge amount of interest in this whole area this morning. We have a lot of viewers dialing in this morning, and some really good questions coming through. Some questions coming in around, the increased use of organic fertilizers. I know you referred to the slurry, but are we seeing an increased usage of organic fertilizers that are byproducts from other industries, for example?
Yeah, I would think definitely, Mark. There is a greater focus at farm level to use the slurry more efficiently. In terms of it's a valuable source of NP and K, in terms of timing, the method of application. Yeah, I think there is a big drive out there, and even alternative sources, like, you know what I mean, the likes of, say, poultry manure, even the likes of pig slurry, that people are seeking it out to meet their crops' nutrient requirements. And I suppose there's the other, factor in there as well, as the carbon element, especially on the tillage soils, that you can put carbon back into the system, and even on your silage ground. Very, very important to get the slurry back out to the silage ground, in terms of returning nutrients, but also putting that carbon back in. Like the research from Johnstown here would show that we can get an extra 1.5 tons of dry matter on the silage ground when you look at, say, straight chemical fertilizer versus where you have slurry in the mix.
So I suppose the other thing going on, Mark, is there's a finite pool of it, and I suppose the real focus is on improving the timing and improving the methodology of use, and focusing on it on where it's needed, particularly on soils where there's low P's and K's, to get maximum value of it. Make sure it goes to the right place.
And of course, you have the clover working away in the field as well, which is the other producer of nitrogen. There was a lot of discussion before about the soil testing that we're doing, that we're very much focused. And I know today we're talking about NP and K largely, but in terms of that broader spectrum of understanding what's going on in the soil and the performance of our soils, is there much work happening there to look at those types of tests where we have the mineral tests, but I know there are some biological tests that are being examined. How popular are they?
You're talking about the biology, Mark. Is it in terms of, like, I know there is work going on. I know Fiona Brennan here in Johnstown is looking at the whole microbial side in terms of the important role of those different communities. I know on the multi-species swords as well that they are finding that they are seeing different microbial communities that are improving soil health, improving soil quality. There is work going on. I don't know, Pat, can you shine
light? And I suppose the other thing that's happening is the Department of Agriculture soil testing scheme now as well, which is using a much broader base of soil tests, with the possibility of the replacement of the current suite of tests, which have some problems with health and safety from some of the products used in them. So there's I suppose it's an investigation into the possibility of using these broader testing, and an opportunity to calibrate them against our current testing. So that's about to kick off with testing going on probably later in December and in January.
Okay. We have some audience questions coming in around the sulfur additions with respect to synthetic nitrogen use, and in particular for well-drained soil. Sulfur helps to bind nitrogen to soil particles, and the root zone improves efficiency. Are farmers widely adopting sulfur use, and is it appropriate, I suppose, in all circumstances?
Yeah, look, sulfur use has increased, Mark, and there is I suppose, a wider range of products on the market, like, you know what I mean, your blends, your nitrogens, you know, sulfur. There is more sulfur out there, and again, we're getting, I suppose, you know, very good responses to sulfur, you know, across a range of soil types. Like, there is less sulfur coming from the atmosphere than what there was historically. You know, even on heavy soils, like, we're seeing up to a 10% yield response from the addition of sulfur. And then to your lighter soils where there's less carbon, less organic matter, we're seeing up to a 43% yield response to sulfur. And again, it's very much driving nitrogen use efficiency. So yeah,
And
sulfur is, yeah, absolutely.
And I think one of the key things there is that the research is showing very significant losses of nitrate to water arising from the use of sulfur, which is hugely significant. And I suppose it's also one of the things that facilitates the overall reduction in the level of N, because I suppose the advice is really to replace some of the nitrogen that would have traditionally been used with N to maintain overall crop production, that you potentially, if you're using some sulfur, you need a little bit less nitrogen.
Okay, so just to clarify that there have been instances where there's increased losses as a result of sulfur. Is that what you said?
Absolutely the opposite.
It wasn't quite clear.
The research is showing that we're getting significant reductions in nitrate losses when sulfur is there. And as Mark said, significant number of farms using sulfur, but I think there's scope for a significant further number to shift to using a sulfur product. And there is a question mark about or a question in the questions there about use of protected urea and sulfur. And
yes,
there are products out there which are a combination of sulfur and protected urea.
Broader question here: why have we been asked to reduce fertilizer usage when we have been years reducing the usage in the last number of years?
And if you go back to, if we can hold on to the 300,000 tons as we've reduced it to over the last couple of years, that's an absolute major achievement. And the 300,000, let's face it, it was achieved in a time of crisis, but maintaining that amount, but now the focus needs to be on the formulation, the type of fertilizer we're using to maximize that environmental benefit of the less polluting, if you want to call it that, fertilizer types. And that's about Mark made the point, I think, very clearly about protected urea. Shifting from can to protected urea will help us reduce the nitrous oxide. Shifting from urea to protected urea helps get the ammonia out of the system. And then the shift to a use of sulfur will help significantly in relation to the loss of nitrates. So those three shifts will help us to achieve that target that we were set of the 50% drop in the loss of a nutrient to the environment, which is the real target we need to be going after.
Now, we do have a question here about how anaerobic digestate compares with other fertilizers, and we will have a speaker next week talking about this in more detail. But do you want to comment on that? Maybe Mark, from your experience.
The nitrogen tends to be more available, Mark. So again, you're probably going to maybe 70 to 80% of, from say 30-40% nitrogen availability. So again, we very, very much treat it like a fertilizer in terms of putting it out very close to when the crop needs it, and again using the low emission technology to recover that nitrogen. So yes, the nitrogen component would definitely be more available. in the digest state coming from those plants.
Probably suited to a tillage environment where you are trying to maintain
well, tillage or
organic.
grassland, yeah, tillage or grassland, it would suit, Mark, yeah.
Are you doing any modelling for nutrient leaching between current techniques and normal use of fertilizer by farmers to understand water contamination? So I suppose that's looking at, you know, the timings, the you know, the various different application methods.
Yeah, no, Dan, there is a modelling being done. Elodie Rowell in Moore Park has been taking a lead on modelling in this sphere of I suppose as well as fertilizer use. It's about management factors around the grazing platform, etc. So there is quite a significant amount of modelling work going on there.
Somewhat of a, I suppose, an obvious statement in a way. If urea and CAN are such an issue, why doesn't the government legislate to reduce or remove them from the market, or incentivize supply of the use of the better alternatives? So I don't think you were ruling out CAN, but certainly urea was there was obvious gains to be got there, I think.
Yeah, and I suppose that there are CAN probably still has a place at a lower level, but to me, the use of unprotected urea just doesn't make any sense anymore. And you could argue that there's there seems to be a small cost associated with it, but I've done some figures on it. A complete shift away from urea would come at a cost to the industry, to the farming industry, of €5 million. But we would get €5 million back of nitrogen, not lost in the form of ammonia. There's 5 million kilos of loss of ammonia from that urea, which would be maintained. So in actual fact, there is absolutely no loss to farmers in terms of the shift to protected urea, and a massive gain for the environment. But also we're going to face very significant fines, which will be orders of magnitude of that 5 million. So to be honest with you, to me, it makes absolutely no sense for any farmer to use unprotected urea from here on in.
And there were initially, I know there were some concerns about the implications on food production and so on, but they've all been
huge amount of work done on showing that no issue in relation to food, no issues in relation to soil. Yeah. So that work has been done.
So I suppose there's a number of specific technical questions here that I don't think we're going to have time to go through, but maybe, you know, for farmers who are looking for advice on what nitrogen or levels to use, Mark, where is the best source of information for them to look at, let's say, their own specific systems, their own specific stocking rates and so on? Where would you start?
I suppose we can direct people into in a number of places, Mark. Like, I suppose, like, really it starts with a fertilizer plan. You know what I mean? Like, you know, work with your local advisor, get a plan done there, you know, through NMP online, and it'll give you specific rates on a field by field basis. I suppose we have the Teagasc Green Book again, which is available there on the Teagasc website. Again, that's a great place to start to see, you know, what's the recommended rates. I suppose we had, you know, the other document there is the SI. Again, there's figures inside in the SI. So there's many sources of data available, Mark. But I think it's very much back to doing a fertilizer plan.
Okay.
And, you know, where you're taking everything into account, the soil test results, the slurry, and then you're looking at what's needed then to balance up or supply the remaining nutrients as in fertilizer.
Yeah, so speak to your advisor. Yep.
There's a question there, just to clarify. Climate Action Plan seems to have much higher target for the use of protected urea than I'm talking about. I was asking, is there an inconsistency? The target of 80 to 90% is for 2030, and where I was looking at a progression through 2025. So I was looking at 2025. So not inconsistent with the climate targets.
Okay, so just to finish out that piece on where to source knowledge, the Teagasc website has a lot of really good fact sheets there, and But I think you're bang on. I mean, the nutrient management plan really is a must for people to really understand what the needs of their crops. And I think it has to be said as well that not every field, we're not looking to drive on every field here either, because it's just, you know, you may have different objectives more if you're based in parts of the country where maybe ecosystem services are more important, or the environmental objectives are different. That has to be reflected there. Is there any research done on which looks at protected urea versus urea can when it comes to nitrate losses from soils?
There's been some. My understanding is that there's a somewhat less potential loss of nitrate through leaching. Not hugely significant, but a slight lowering is my understanding.
Okay.
Yeah,
we have. Yeah, sorry, Mark. Go ahead.
Sorry, and the work would even show, Mark, that we can reduce our nitrogen. You know, there's a long-term fertilizer trial here in Johnstown Castle that we can reduce our nitrogen by about 10%. You know, when we replace ordinary urea with protected urea. So again, you're retaining more nitrogen in the system.
We have a lot of questions coming in here, so we're going to try and just get through them. We have 3 minutes left, so let's try and get through them. The question in relation to biostimulants and their effect on nitrogen use efficiency. Is there much work happening in this area, or is it early days?
Yeah, look, there is a lot of products out there. I think it is early days around the research. And look, yeah, I'd imagine in time that there may be products there that will bring, you know, something to the equation in terms of improving nitrogen use efficiency. I don't know, Pat, do you want to make any comment? Or...
Yeah, no, I agree with what you're saying. There's some that seem to have prospects. There's others that may not have, and there's a requirement for, I suppose, research in this space to look at them. And I suppose one of the challenges is there's been so many have come out in the last number of years that doing large scale trials on all of them would be extremely challenging.
Is there any research on foliar applications of nitrogen? Is there?
There is work done. Yeah, there is a limited amount of work done, Mark, and I think there's work kicking off or starting. Yeah, again, look, foliar nitrogen, it's the same as can of urea. It's a source of nitrogen. It's very targeted. You know, again, I like it in terms of, you know, the target or the precision application. And yes, yeah, it's a source of nitrogen. And again, I'd say there is work done that would give similar performance to both can and protected urea.
You mentioned the increase of fertilizer use in 2018 in response to the drought. Can you comment on the understanding? Was this effective, or did this actually give improve production? And I suppose the question is, if we're in that scenario again, are we going to what sort of advice are we going to be giving people?
Okay, I think we put up our hands and said we learned a lot, and farmers learned a lot in 2018. And 2018 was a long extended drought right into the August period. And there was very significant fears that there would be shortage of fodder in that year. There was a poor allowance for, I suppose, the amount of nitrogen that's naturally within the soil, particularly when you get drought and a breakup of the soils and releases. And there was a degree of panic, I think is how you might best describe it, in terms of the use of nitrogen and trying to drive production. And since 2018, we've had a number of smaller but quite significant droughts. And the amount of nitrogen that has gone out in response to those has been very much less. So it was, there was a degree of lessons learned. We saw, even naturally, there tends to be a spike in nitrate loss to water after a drought, but that was exacerbated by the amount that was used. And we have seen since then that the advice has been very strong about the cutting back on nitrogen in those drought periods, and only coming back in again with nitrogen when those droughts end. So a lot of learning in that period. We saw a spike in nitrate losses to water that has been largely reversed since then, but it does take a while. If you have nitrogen going to groundwater, it takes a few years for it to come out of the system. So yeah, hands up, mistakes made.
Okay, well, look, we are now a little over time and we still have loads of questions. So unfortunately, we're not going to be able to get through everything, but I think it'll be nice to just finish on a comment that we've received here. And it says that farmers have to be given huge credit for changing practices to allow for a reduction in the chemical use, in nitrogen use across the country. If it was just price, farmers would have produced much more milk in 2022 at record prices. So that is a nice way to wrap up today's session, and that there has been a huge change, huge response from farmers on the ground. And also, I think we must credit the work of advisors across the country as well, in terms of facilitating and supporting that change, and of course the industry as well. I think the Signpost Programme, which you're working with, Mark, is doing great work in this space, and I think people should check out the website if they are looking for more information about how they can contribute to reducing their greenhouse gas emissions.
Mark, to paraphrase from somebody, a lot done, but we're only halfway there. A lot more to do in this space.
A lot more to do, but look, 2030 is looming, so we have to keep the pressure on to drive down these the emissions. But look, we are making progress. So thank you, Pat, and thank you, Mark, for joining us this morning. And next week, we're going to be joined by Dr. Maurice Deasy, who's going to be speaking to us about anaerobic digestion and the opportunities in Ireland for anaerobic digestion. I want to say thanks to Mary O'Loughlin for helping us this morning on the technical side of things. And we look forward to seeing you next week. And for any of the little people that are watching us today, do enjoy the Late Toy Show tonight. It's hard to believe it's a year later. I cannot believe where that year is gone. Christmas is only around the corner. So if you're staying up late tonight, enjoy the show. Okay, we'll see you next week. Bye for now.